Hello everybody, my name is Malemba Sakom. I'm an MTech student of Tezpur University, Department of Food Engineering and Technology, and I'm going to share my presentation on the topic optimizing packaging. Here are the topics that I'm going to cover in my presentation. Introduction, issues in optimizing packaging, the BTT precision packaging concept, example of food packaging optimization, and lastly, conclusion. Introduction. Package design has great significance for the success of foodstuff nowadays. Packaging has many other functions and requirements which it has to fulfill more and more effectively and economically. There is a need to make the optimal package that satisfies all the functional requirements in addition to meeting environmental and demand costs as well as possible. The BTT precision packaging concept developed in the Technical Research Center of Finland is a new and unique tool to optimize packaging for foodstuff. So what is a BTT precision packaging concept? The VTT precision packaging concept is a customized tool for optimization of food packaging, and it is based on the predetermined minimum shelf life needed to allow the packed foodstuff to reach the consumer table from the factory. The shelf life is naturally chosen to suit the market and business strategy of the company. Issues in optimizing packaging. Aim in optimization of food packages is to create a tool for decision-making policy for launching new product, advantageously help food manufacturers, packaging material, and packaging manufacturer to evaluate and compare the feasibility of their new and present product. The considered factors covering the performance in logistics, marketing, properties, consumer convenience, cost, and environmental stress. The general goal in package optimization are cost effectiveness of the packaging process and environmental issue. Example, source reduction of the packaging material. Performance in logistics. It is essential that a package has sufficient mechanical strength to protect the packaged product from environmental stress during distribution and storage. An optimized food package minimizes the waste in the overall packaged product. New packaging solutions should also be technically feasible. Marketing properties. The marketing properties of the package should be fulfilled optimally and cost effectively. Only adequate investment is needed to fulfill the needs. For example, package design in terms of packaging material consumption, decoration and information. It is important that package designer, manufacturer and user cooperate for optimum package. Cost. A cost competitive package is a benefit for both the packaging and the food manufacturer. A packaging innovation requiring a minimum of investment and giving consumer product delight at affordable prices can be seen to a very attractive goal. Consumer convenience. Properties of the package include being easy to handle, carry, store, and dispose of, reuse, as well as its openability, resealability, and microwavability. Environmental stress. There is a need for environmental stress from the packaging material and packaging. The necessity of a low ratio of packaged product to product weight, the need for a little of the packaged volume to be waste as possible, and the incineration possibility of different packaging material. The BTT precision packaging concept. The first task is to specify the required shelf life for a foodstuff and determine the basic requirement for this food package. For example, by using shelf life prediction model. After that, it is possible to choose different combination of package type and to optimize the package. And here are the steps of optimization. Scoring the tested package type. Evaluating the importance of packaging characteristic. Calculating the coefficient for each of the characteristic. Calculating the optimization result of each of the tested package type. Determination of basic requirement for packaging. Minimum required shelf life for foodstuff, storage test, minimum package requirement for foodstuff, alternative packaging and storage combination, package optimization, scoring the selected alternative packaging type, evaluating the importance of package characteristic, evaluating the coefficient for the characteristic, calculating the optimizing result of the package type, and lastly, optimal package. Steps for modeling of shelf life of foodstuff. selecting factor and responses, selecting the experimental design method like screening or a more extensive method, carrying out tests, analyzing results, making shelf life prediction and determining the minimum package requirement. Quality parameter in shelf life testing, sensory and chemical analysis and microbiological determination, determining different package and storage combination. Scoring the selected alternative package type. The selected alternative package type giving the same minimum required shelf life are first scored by rating different characteristics of each package type. As an example, the following package attribute can be used in a precision packaging concept. Number 1. Mechanical strength of the package. Number 2. Suitability with respect to packaging standard. Number 3. Ratio of package weight to product weight. Volume of the package waste. Possibility of incineration. Life cycle assessment of packages. Marketing properties of a package. Consumer convenience. Consumer attitude. Cost of packaging material. Indirect packaging cost. All these characteristics are scored on the scale from 1 to 5, with 1 corresponding to 4 and 5 to excellent quality. Evaluating the importance of package characteristics. After the characteristics of the selected alternative package have been scored, the importance of characteristics is evaluated by the food and packaging material manufacturer, the wholesaler, and independent packaging technology and plastic industry specialists. Here's the formula for calculating the coefficient. The coefficient I for each of the characteristics is given by I is equal to 0.4 IF plus 0.25 IP plus 0.25 IW plus 0.1 IS. Calculating the optimization result. The score S given to each of the characteristics of the tested package is multiplied by the corresponding coefficient I given to these 9 characteristics, where OR is the optimization result of a certain tested package type. For an optimized package, the mechanical strength of a package and its suitability with respect to packaging standard are considered for as the essential requirement that all packages should fulfill before being launched. Therefore, this requirement can be ignored when calculating the optimization result. Here are some of the examples of food packaging optimization, like gas pack cheese slice, raw chicken leg, roasted chicken ball, and ham pizza. Gas pack cheese slice. According to the result of the modeling test, an ideal gas package for sliced measured cream cheese, considering a shelf life of 8 weeks, temperature 6 degrees Celsius, and keeping its quality to the maximum, may have the following properties: protection from light during distribution, oxygen transmission rate of packaged material 5 to 95 centimeter square meter square 24 hours at 23 degrees centigrade, relative humidity 50%, and 1 atmospheric pressure. Carbon dioxide concentration, residual oxygen level, head space volume. The next step was to choose the different packaging alternative for slices. The most important factor affecting the optimization result were indirect packaging costs, marketing properties, and the cost of packaging material. The optimization result suggested that the selected alternative package differed most in the cost of their packaging material. And the second example, gas pack raw chicken leg. According to the result of modeling shelf life test, to achieve a maximum quality for raw chicken leg for 7 days under the existing distribution condition, the package parameter could be the following: oxygen transmission rate of package, carbon dioxide concentration, residual oxygen level, protection from light, head space volume. The next step was to choose the different packaging alternative from roasted chicken ball. The most important factor affecting the optimization result were indirect packaging costs, cost of packaging material, and marketing properties. Gas pack pizza. According to the result of the shelf life modeling test and other literature data, an ideal package for ham pizza, considering the shelf life 16 days and keeping its quality to maximum level, may have the following properties: protection from light, oxygen transmission rate of the packaging material, carbon dioxide concentration 10 to 40%, residual oxygen level greater than 1%. The next step was to choose the different packaging alternatives for ham pizza. The most important factor affecting the optimization result were indirect packaging costs, marketing properties, and costs of packaging material. Optimization results indicate that flow pack were better than thermoform trays, the only benefit of the trays being the lower cost of packaging material. And the conclusion. The BTT precision packaging concept can benefit the packaging industry, for example, by providing the means for comparing different package types. The concept can help the food industries in choosing plastic package material and considering the demand of logistic, cost saving and shelf life, and improving competitiveness. In addition, it gives packaging material exporter a method of optimizing material in the different conditions for exporting countries and helping in the after treatment of the plastic based packaging material. With this, I would like to conclude my presentation and thank you.